So this is LeetCode 258, add digits. Here we're given an integer num and we're told to repeatedly add all its digits until the result has only one digit and return that. So if we have 38, you're going to add the ones place 8, and then you're going to add the tens place 3, and so on and so on. And from there you get a sum of each of those digits, and you just repeat the same process until that sum is a single digit. So it asks if you could do it without any loop or recursion in big O of 1 runtime. That's pretty hard to do, and I always find just doing the simple brute force methods, as long as they're not just crazy long, is always the best way to go about this. So I'm going to use recursion to solve this, and when you're creating a recursive solution, you always want to start with a base case. So here I'm going to just check if there's only one digit in the number. So to do that, we just check if number divided by 10 equals 0. And there we're just going to return the number, because if you have like 9 divided by 10, that's going to equal 0, because this division sign right here floor divides, so it automatically is rounded down to 0. So after here, you're going to want to int sum to keep track of the sum, and you're also going to want to int multiple. So this is just going to be 10. So I'm putting it in a variable. You don't really need to. I'm just going to call it int multi to 10. And we're going to just do a while loop through basically each one of these, each place in the number. And by doing that, we're just going to get the first one here, which is going to be 8. And then we're going to get the 3, and then so on. So to do this, it's going to be floor division along with the percent sign division to see if they get the remaining amount. So we're going to say while the number is greater than 0. So that's going to be our base case for this while loop. We're going to say the sum equals, we're going to do prefix notation as well. The sum is going to equal number divided by number percent 10. If it's 38, 38% 10 is going to give us 8, and we're going to add that to the sum. Then from there, we're going to have, we still have the same number of 38. We're going to want that 38 to drop, or basically be divided by 10. So we'll just say number equals number divided by 10. So now this will make the 38 divided by 10, that's going to give us 3. And from there, it's just going to continue on, and now we have 3. 3% 10 is going to be 3. And then after that, we're going to have our new sum, and we're just going to want to pass that in again to add digits. Because eventually the base case that we have here will hit, and once it hits, we have the solution. Well, let me return that. So this gives us pretty fast return time. I believe this is still big O of, I'm not sure the specific big O, but it's not big O 1 because it loops through each digit in the number. So the big O of 1 method, which is quite hard. I don't really think anybody's going to figure this out on their own, but it's called, I think it's called like the digit root method. But basically, it's a weird method. I'm going to write it out really quick, but it's pretty simple. You're going to check if the number equals 0, and you're just going to return 0. Then you're going to check if the number divided by 9 has no remainders. You're going to return 9. And then you're going to check if the number, or then from here, you're just going to return number percent 9. So this is the linear time solution. I think it's quite hard to actually figure out on your own, so don't sweat it. The simple solution was the original brute force method, right back here. And that's it. That's the best method to just learn, and that's the solution.